There are 7 questions in the Traveler demo for general chemistry. The first 2 or 3 would be the ones to really hit and hopefully get faculty interested in looking more at SmartWork 5. The first one is a mixed question that contains labeling and numeric entry. The second question is a chem equation question, and it also has a tutorial. The third question, if you can get that far, contains an animation as well as a numeric entry as well as some multiple choice questions. And if you can keep them interested, the fourth question is a molecular drawing question, so drawing something in 2 dimensions. And the last 3 questions are there so you can showcase different question types of sorting and ranking. And then the final question, chem equation, is a more complex entry for a chemical equation. So whereas question 2 is simply showing a formula, question 7 is showing the entire equation. So let's take a look at question 1. This is a great question to highlight the format, the white space, the layout, to comment on the hints for each part, how the periodic table link is there, the hint here in the second part, how they're unique. This would be a great question to highlight the ebook link and bring up the ebook. This is a great ebook section because it gives chemical equations and mathematical equations. It talks about how to solve math equations, how to cross out units, but it also has a really great image here highlighting the pedagogy Stacy Bretz brought into the book, where we see our particular representation. We see the macroscopic representation of the glassware, and we even see the symbolic representation of the symbols that are describing the chemistry that's happening in the image. So this is a great ebook link that not only showcases the pedagogy, but helps the students answer the question. So if we go back to the question, what's great about this question is it's visual and it's a conceptual as well as mathematical. So the concept is students intuitively understand that when they dilute something, it's going to be highly concentrated. And as they dilute it, it becomes less intense in color until you finally have something that is just water or close to water, right? Think about Gatorade if you dilute it, or Kool-Aid if you dilute it. So that's the kind of thing that's happening here. So students intuitively know that. And this last part, they're entering in a numeric answer. You can just try something totally wrong, but the cool thing is if you do X or E, it brings up that scientific notation where they can put in any number. So I just put in something random here. This is not the right answer. Part 1 is correct, part 2 isn't. So you can submit that, and you could even show that you can get correct feedback for one part, incorrect for another, and how that feedback helps. At this point, I would probably give up and view the solution, showing how the correct solution is available, and the explanation is a full worked COAST answer. So you can see that collect and organize, the analyze, the solving of both parts mathematically and conceptually, and then the think about it to further apply it to further apply their knowledge of what they just learned to other concepts in the class. So at this point, we'll go back now to question 2. Question 2 is a tutorial question. So if you expand it here, you see that there's one goal question of combustion analysis, but there's 3 components to it if the student needs help. So you can think about this as if a professor is helping a student in their office hours, they would guide them to the answer by going through specific steps or a process. So tutorials are geared to help the student answer a more complex or challenging question by guiding them through the steps to get there. These steps, which we call child questions, tend to mimic COAST. So we see collect and organize, analyze, and the solve component. They mimic COAST, and they're guiding that student to get to the final answer, but they're not giving them the final answer. So, and they also are not graded. So the whole point of answering these is to help the student get to that end point without giving them the answer. So let's take a look at what this looks like. So in this question, we see the tutorial. There's again a great image that's highlighting the pedagogy from the book with the particulate representation, the macroscopic, and the symbolic. There's still an ebook link. There's still hints. There's still the link to the periodic table. They can always give up and view the solution. So all that stuff is still there. They could try the tutorial lesson immediately, or they could input an incorrect answer like C2H3. I use the shortcuts to add the 2 and the 3, but you could also show how you could use the tools in the chem equation bar to add the 2 and the 3. Now this is a programmed incorrect answer. And that's going to bring up answer-specific feedback, but it's also going to bring up the option to launch the tutorial lesson. So I'm going to launch the tutorial. Oops, I hit that wrong. Launch the tutorial lesson. And when I launch the tutorial, I'm given, in the student view, the 3 general steps or things I need to do to figure out how to get toward the final answer. Now you can, at this point, close it. If the student thought, hey, I'm done, I get it now, they can close it and go back to the main question. Or they could just skip to question 2 or 3 if that's where they're stumped. Or they could just click here and start the tutorial. At this point, I probably would not enter in incorrect answers. I would just showcase the process. Say the first thing a student would need to do to answer this is know what the molar mass of carbon dioxide in water is. So this question is guiding them. It has all the things they need, the hints. It has answer-specific feedback. They can give up and view the solution. If they do that, that will not affect their score, right? It says right at the top, tutorial questions are not graded. They're just there to help. Then go to question 2 and highlight how the next part in answering this tutorial is to understand how many moles there are in the number of milligrams that are collected. So in the number of moles and the amount of milligrams, so we can go ahead and figure out that. Again, there's hints and they can give them a view solution. There's ebook links and there's feedback. The final question is the student knows how many moles and they have to figure out the empirical formula. So this is the last thing they need to do before they get to that final answer of the molecular formula, which was the main question. Now, the answer here is actually C2H3, which was the, capital H, H3, which was the incorrect answer that we programmed before. This is actually the correct answer for this one, right? And it talks about the molecular formula and relates the molecular and empirical formula. If they view the solution, it actually tells them, hey, this isn't the goal. We need the molecular formula. This is how you would get it from what you have so far. Okay, so this is getting them almost to the final answer, but not quite. But hopefully it's enough to help them figure out what they were missing. So we'll close the tutorial and go back to the main question. And remember, C2H3 was incorrect there. Now we're going to enter in C20, C20H30. And that is the correct answer. So we see that we get feedback. What's nice about this is you can review the tutorial lesson or try it again. So again, it's up to you how detailed you want to go into the tutorial. If you just want to highlight the questions, you want to look at all of them, you want to maybe answer this first and show feedback and then show the tutorial. But the tutorial is there to guide the student to how to get to this final answer. So let's go back to the demo and look at what the third question is. So the third question in the demo is a combined gas law question. It's an animation. So it includes a chem tour. Here we see the chem tour. This will actually be updated shortly to the new format. So if you're looking at this maybe in, say, end of August or September 2018 or later, you might see a slightly different look than you're seeing here. But it's basically telling students to go to slide 3 and 4 to view the animation. So let's jump there.
The ideal gas law. Watch what happens.
So here's an animation that they might view. Notice they can interact with this and change what's going on. So this helps them understand the concepts. What you might want to do here, again, highlight the hints and the feedback, but a programmed incorrect of 50, a programmed enter an A and A. And what you'll see here is feedback that is, and I submit this, you'll see some parts are correct, some are incorrect. So a student can then try again and adjust and change their answers to the parts that were marked as incorrect and not change the correct part. So the feedback is really nicely specified for each part. So the correct answer that we'd like you to put in is 0.0200. Leave this as A, and then this is B. When you submit the answer here, you'll see specific feedback for each part, which is very exciting to see lots of green, and they're excited about this. But what you could point out is that if you give up and view the solution, notice the programmed answer is 0.0203, but you put in 200. This is highlighting the tolerance that is available with our numeric questions. So there's a plus or minus 2% tolerance for most programmed answers. This allows for rounding and other issues that occur in calculations. At this point, if they ask about sig figs, you can comment that our answers are always displayed to the correct number of sig figs. Significant figures are sig figs, but that the student does not need to enter their answer to the correct number of sig figs to be marked correct unless it states so in the question. So we do display our answers to the correct number of sig figs here in SmartWork 5, but students do not need to enter them that way unless told to do so in the directions. All right, so let's look at the last couple questions. The last couple questions here, we see there's a sorting question and a ranking. Here you probably just want to go and show them the conceptual questions. There's a lot of good visuals in these questions, and just highlight the different question types that we have and feedback that's available. But really it's just kind of breeze through those and show that we have them. And the last question, if you're able to get there, my guess is that a lot of professors would maybe want to try this one themselves. But if not, a few things to highlight in this last question, if you're able to get to it, is this is a chemical equation entry question. So we see a full chem equation needs to be entered, a balanced chemical equation for the formation of rust. So the correct answer is shown here if you ever give up and want you to write it down or something. So we have 4 irons that are solid plus 3 oxygens gas give 2 iron 3 oxides that are solid. So that's the correct answer. So what you could do is put in an incorrect answer that, first of all, has the right structures or elements here and the right states of matter, but they're not balanced, right? So notice the difference here is that I do not have the 3 and the 4 and the 2 in front of the structures. Also notice I wrote the O2 oxygen first, then the plus symbol, then the iron, which is Fe, right? Up in this programmed answer, Fe is first. I'm going to submit this because this gives specific incorrect that's telling the student that the answer is not balanced or the equation is not balanced. So we can go and try again. And at this point, we can balance it by putting in the 3 and the 4 and the 2, right? This is a much more complex entry than the other chemical equation. So this might be something that, maybe it's okay for you to open up and view the programmed answer on a piece of paper or give control of the computer to the professor for them to try it at this point. What I like here is that the oxygen is listed first and the iron is second as opposed to the programmed answer. They're flipped. And so what that highlights is the flexibility in the grading so that it doesn't, while the correct answer can be accepted in a couple of verified formats, not necessarily the one that's been shown. Okay, So hopefully that was a little bit of an overview that's helpful to understand the demo. Again, the thought is that questions 1, 2, and 3 really highlight a lot about the pedagogy and the versatility of the tools, the links, the ebook links, the feedback, etc. Question 4 highlights the drawing tool. 5 and 6 are to highlight different question types, and 7 is to a more in-depth look at writing chemical equations.